For absolute value inequalities, there are two cases to consider: if the absolute value is less than a number or greater than. Let's focus on the less than first. So in example 1, I'd like to try to guess what the answer is for the absolute value of x is less than 4. So just like with a linear inequality, when we had x is less than 4, it meant we could go right up to but not include 4 in my answer. So on the number line, I'm going to put 4 here and just check to see if 4 works in this inequality. I put 4 in place of the absolute value. Is the absolute value of 4 less than 4? And the answer is no, because there's no equal sign on the inequality. This is false. And because of this, I'm going to put an open circle at 4. So we couldn't actually use 4, but only because there's no equal sign here. Now, if we check, let's say 3, 2, 1, 0, -1, -2, -3, -4, and so on, I'm going to plug those in place of x and see if they make this true or false. So let's start with, I guess 3. Is the absolute value of 3 less than 4? And well, yeah, of course, the answer is yes, because 3 is less than 4. So that's true. I can circle that one in. All right, for 2, is the absolute value of 2 less than 4? I mean, that's also true because 2 is less than 4. And the same thing is going to hold true for 1 and 0. I mean, clearly, if you put 1 or 0 here, you get that those numbers are less than 4. But let's check out -1, -2, -3, and -4. Let's try those. For -1, is the absolute value of -1 less than 4? And the answer is yes, because 1 is less than 4. Something kind of weird happened there. It's a little bit different, but okay, it still is true, so I can circle in -1. -2 in absolute value, is that less than 4? Sure, because 2 is less than 4, so I can include that one. The absolute value of -3, is that less than 4? Sure, because 3 is less than 4, so that's good. But then we come across to -4, so that's here. If I try that one, is the absolute value of -4 less than 4? And the answer is no, because this becomes 4 is less than 4, which we already know is false. So I'll put an open circle and note that the answer is everything that is in between those two values. So this is different. When you say the absolute value of something is less than 4, that does mean you start at 4 and you go to the left, but you have to stop when you get to the negative of that number. I think it'd be worth, plugging in maybe 5 and -5 just to see if those work, but I think those are going to be false as well. If you check the absolute value of 5, is that less than 4? And of course the answer is no, because 5 isn't less than 4. But putting a negative next to it, it doesn't make it work either, because again, you get 5 is less than 4, and we know that all of those are false. Here's the takeaway. If you have the absolute value is less than a number, it means you're less than that number, but you're greater than the negative of it. Let me write that up above here. What this means is two things. It means x is less than the number, but it means something else. It also means that x is greater than the negative of that number. We call this a compound inequality. Just because there's two pieces. And this is often written as one piece. Like this. X is less than the number a, but it's also greater than the negative of that number too. So whenever we see the absolute value is less than a number, it really means this. It's less than a, but greater than -a if we're talking about just x. So how do things change if we switch it from less than to, in this case, the absolute value of x is greater than a number? So I'll again go to my number line and try to see if I can reason this out. So I'm going to start at 4. Maybe I'll put 4 right there. Okay, 4 definitely not going to work. There is no equal sign here. So I'm going to put this open circle again at 4. Now I'll try, here's 3, 2, 1, 0, -1, -2, -3, -4, and so on. So over here is -4. If I try 3, Is the absolute value of 3 greater than 4? And this is false because 3 is not greater than 4, so that's no good. So this time, we have this greater than, meaning we're not going to the left. In fact, it must mean that we're bigger than 4 going in this direction. So I really want to try numbers like 5, 6, and 7. Let's see if they work. Is the absolute value of 5 greater than 4? Yeah, because 5 is greater than 4. Same thing for 6. Is the absolute value of 6 greater than 4? Sure, that's true because 6 is greater than 4. So 5 works, 6 works, but so does 7, 8, and 9. And in fact, everything that is greater than 4 works, all that stuff. I already know 3, 2, 1, 0, -1, -2, -3, -4. None of these are going to work. So I'll again put this open circle at -4. But what about -5, -6, and so on? Let's try those. Is the absolute value of -5 greater than 4? And the answer is yes, because it switches to 5 is greater than 4. So I do want to include this. And what about the absolute value of -6? Is that greater than 4? Well, sure, because 6 is bigger than 4. In fact, everything that is less than 4 also works. Here's my answer. If you have greater than, it does mean you're greater than 4, but then down at the negative of that value, you're less than it. I'll write that up here. The absolute value of x greater than a means two things. It means x is greater than a. That's referring to what happened here. But we write or as another possibility, x could be less than -a, which is referring to this stuff here. This is also a compound inequality. And it's customary just to leave it with the word or in between it, saying that it's this piece or it is this piece. Whereas in the previous one, it was just one piece in between that we broke into two separate pieces. So if you see greater than, it means two things. X is less than the negative of that number, or it's greater than the number itself. And for example 3, I want to combine all of these ideas in just a slightly more complicated example. When is the absolute value of 2x plus 1 less than 5? So the difference is, it's not just x, in fact it's 2x plus 1. But in terms of the cases, it's going to be our first case that we encountered, where we have something in absolute value that's less than. So what this means is two things. It means the thing in the absolute value, which is 2x plus 1, it means it's less than 5, but, and I'll put the word really, and you also have that 2x plus 1 is greater than -5. This means we're stuck between two values. We're less than it, but we're also greater than the negative of it. So what I'll do now is just solve each of these individually for x. So to get x by itself, I'll subtract 1, divide by 2, and I'll do the same thing over here. I can do this all in one step. I'll first take 1 from both sides, but I can do the same thing on my other inequality too. I get -6 is less than 2x, and on this other one, I'll put and in between them, I get 2x is less than 4. To get x by itself, I can divide both sides by 2. And in the first one, I get -3 is less than x, and x is less than 2. Let's plot these two things here and here on my number line. I want x to be less than 2, so let's say 2 is located right here. I'll put an open circle at 2 because I'm not including it, and less than it means I'm going in this direction. But I have to stop. I have to stop when I get to -3. I go down to it, but I want to be greater than -3 at the same time. This told me how far I could go in this direction. This told me how far I could go in this direction, and the less than meant I took everything in between.